Section 2.2, example 6, solving rational equations with a binomial in the denominator. So for this example, we're going to solve the following rational equations and state the excluded values. So what we were used to before, we find our least common denominator, multiply both sides by that. Here we have a binomial though. So binomial is an entire phrase. So we can't just say, oh, there's an X here and an X here. What we have to do is find something large enough that's divisible by the two of them. So for this first example, we are going to move this out of the way really quick. So here our LCD is going to be just a tiniest bit different. LCD is something large enough that's divisible by both x minus 6 and also x. So here's something divisible by x minus 6. It looks like it's just going to be our x minus 6. And we have our x minus 6 divided by x minus 6. We have a whole number, so that's exactly what we want. And now what about x? Is this whole thing divisible by x? Ooh, no, it's not, because we would have to have an x on the outside for it to divide out with. So what we're going to do here is just multiply both, well, not both sides. We're going to multiply our LCD by x. Now this is large enough to be divisible by these two different values. So our x minus 6. So x times x minus 6 divided by x minus 6, those two divide out, that's equal to just x. And also with x, we're dividing both sides, or our LCD by x, leaves us with x minus 6. Either way, we get rid of the fractions, which is exactly what we want. So we're going to multiply both sides by this. So 3 over x minus 6 is equal to 5 times x minus 6. And what we're going to do here is multiply by our LCD. X minus 6 times x. X minus 6 times x. Over here on the left side, the x minus 6 divides out with the x minus 6. Over here on the right side, oh, it looks like I wrote it down incorrectly. There we go. So now the x divides out with the x. Now everything matches. And now we just have to multiply by whatever we have left over. Here we have the x that we're going to distribute here. Over here, we could distribute the 5 through our binomial there. So over here, that leaves us with 3x is equal to, over here we have 5 times x. That's going to give us 5x. And we have 5 times negative 6. It's going to give us a negative 30. And now from here, what we want to do is make sure that we get all of our variables over to one side, everything else to the opposite side, so that way we could divide and isolate our variable. So here, I think it's going to be easiest to move this over to the left side, have our left side our variable side. So minus 5x on both sides. So negative 2x is equal to negative 30. And now to get x by itself, we are going to divide by that negative 2, because that negative 2 is being held together with x using multiplication. So to undo that, we're going to divide, opposite of multiplication. Negative 30 divided, or negative divided by negative gives us a positive. And then 30 divided by 2 is going to be 15. So x equals 15 is our solution, but we have to make sure that we have rational solutions. So what we're going to do is see where we're not defined, or where we're undefined. So an undefined number is going to be whatever makes this fraction have a denominator of 0. So what we're going to do is set the denominator is equal to 0 and exclude them from our solution set. So we could start off with this fraction right here. So 3 over x minus 6. We know that x minus 6 cannot equal to 0. So we're going to add 6 to both sides. So x is equal to 6, or x cannot be equal to 6. That's one of the solutions, or one of the excluded solutions. And lastly, we have the other fraction over here, x. So x cannot equal 0. And there isn't any computation that we have to do there. So since our only solution that we found over here was 15, 15 is not 6 and 15 is not 0. So therefore, this is our one and only solution for this one. And now I did kind of cheat and kind of show you guys the longer version. What we could have done here is seen this and multiplied by both sides by x. When we multiply by x, these x's divide out. So we're left with 3x, which is exactly what we ended up with over here. And same thing on the other side, we can multiply both sides by our x minus 6. Over here, these divide out, and then here we have 5 times x minus 6. You distribute it, and this is what we end up with here. So now this only works when we have one fraction equal to one fraction. We call this cross multiplication because we can multiply across this way and multiply across this way. So numerator times denominator, then denominator times numerator. It only works if we have fraction equal to fraction. So how can I write it? So numerator, denominator, fraction equal to numerator, denominator, another fraction. So it only works when we have that. It's not going to work for these other two problems because it's not just one fraction. I mean, we could make this one fraction over here. Same thing over here. We can make that just one fraction, but it might be a little bit easier to use the same steps that we found over here using our LCD and multiplying both sides by our LCD. So let's give it a try with part B. All right, so with part B, we're going to look for our least common denominator. So a value big enough to be divided by all of the different denominators. So here we have x minus 3, and 2. LCD, we could start off with this part, x minus 3. Remember, a whole binomial is going to be part of our denominator or our LCD. All right, so x minus 3, we have x minus 3 divided by our x minus 3. Those two divide out, we end up with the whole number. Perfect. What about this one? X minus 3 divided by x minus 3 equals 1. All right, perfect. Got rid of all the fractions there. And lastly, denominator of 2. X minus 3 divided by 2. We still have a fraction. So what we're going to do here is, oh, forgot to do that part. All right, so what we're going to do here is multiply by a 2. So that way it's a number divisible by 2 or a value divisible by 2. So now with 2, we're dividing our LCD by 2. And, well, actually x minus 3. But we end up with no fraction. So it looks like we found our LCD, and now we're just going to multiply both sides by our LCD. We can't do our little cross multiplication shortcut because we don't have fraction equal to fraction. So we have to do it the long way. So we have our x over x minus 3 is equal to 5 over x minus 3 minus 1 over 2. We're multiplying both sides by our LCD, which is 2 times x minus 3. 2 times x minus 3. When we multiply over here, our x minus 3's divide out. And our left-hand side leaves us with 2 times x. Perfect. And now we have this being multiplied to this fraction, but also to this fraction. Let's start with this first fraction. So x minus 3, when we multiply our LCD, x minus 3 is going to divide out. Then we have 2 times 5. So 2 times 5 gives us 10. And we have to keep the sign here. So that's going to be minus. And lastly, when we multiply our LCD to the second fraction, our 2's divide out. So now we have 1 times our x minus 3, which is just going to be x minus 3. I'm going to put it in parentheses because we do have something that's being multiplied here. So we're going to distribute that negative through. So now we have like an equation that we could solve for. So first thing, we're going to distribute that through. So 2x is equal to 10. Negative times positive is negative, so negative x. And negative times negative is positive, plus 3. And continue to simplify. 2x is equal to a negative x. Then we have 10 plus 3. That's going to be 13. Plus x to both sides to get all of the variables over to the left side. That leaves us with 3x is equal to 13. And lastly, to get x by itself, isolate the variable, we're going to divide both sides by 3, leaving us with x is equal to 13 over 3. And now we can't say that that is our solution just yet. What we're going to do is check to see what our excluded values are. So remember, we have our denominator. It cannot equal our denominator, or our denominator cannot equal 0. So we're going to say our first denominator, x minus 3, cannot equal 0. And let's see what value we're not allowed to have first. So x equals, or x cannot equal 3. All right, x cannot equal 3. And we have the exact same computation here, x minus 3. We already checked that one. And 2. So if you really wanted to, we could say that 2 cannot equal 0. But we already know that 2 cannot equal 0. So our only excluded value is going to be x cannot equal 3. We come down here to C, and we have x is equal to 13 over 3. That's not equal to 3, so we could automatically say that that is our one and only solution for part B. And it looks like we're running out of space. Let's grab this last problem. And same thing here. So we cannot use our cross multiplication. We have to find our LCD and our solutions that way. So let's give it a try. So x minus 2, starting with our LCD. X minus 2. And starting off with this one, x minus 2 divided by x minus 2. All right, all fractions are gone. Same thing here. Fractions are gone. Then we have 2. Yeah, that's not going to work. Even though we do have a 2 right here, it's not a constant multiple out here for us to divide it out. So here we go. Our LCD is going to be multiplied by 2 over here. And let's check that last one. All right, no fractions here, so we're good there. So our LCD that we multiply to both sides is going to be that x minus 2 times 2. So start by rewriting the equation. And we multiply by the LCD, which in this case, x minus 2 times 2. Same thing over here, x minus 2 times 2. So over here on the left side, x minus 2 divides out with x minus 2. And we're left with 2 times x. So 2x. And that's it for the left side. Now moving over to the right side, we're multiplying our whole fraction or our whole LCD by the first fraction. So here 2 minus or x minus 2 divides out with x minus 2. So we're left with 2 times 5, which is 10. And we keep the sign of, we keep that sign. So bringing it down. And now we have our LCD multiplying to that second fraction. So we have x minus 2 times 2, and we're dividing it by 2. So the 2's divide out here. So now we have 1 times our x minus 2. And we're going to keep that in parentheses because we're multiplying by this negative. This negative is going to distribute to everything inside those parentheses. And next step is to expand everything out. Then we're going to solve for that variable or get the variable isolated. So we have this negative that we're going to distribute to these two terms here. 2x is equal to 10. Negative times x is going to be negative x. A negative times a negative 2 is going to be a positive 2. So on the right side, we could combine like terms. So left side is going to remain the same. Can't do much there. But here I have term and term. Let's get our variable in first. So negative x. And then we have 10 plus 2. That gives us 12. So plus 12. Now to get all the variables over to one side, I think it's going to be easiest to move this over to the left side. So we're going to add both sides, or add x to both sides. 3x is equal to 12. And now from here, to get x by itself, we're going to divide both sides by 3. X is now equal to 12 divided by 3 is 4. But we can't say that that is our only solution, or that is a solution to this equation. We have to see what values we have to exclude. So from here, we say that x cannot equal or x minus 2 cannot equal 0. So coming over here, we're starting with that. X minus 2 cannot equal 0 because if it does, we have a 0 denominator, which is bad in math. We can't have that. So add 2 to both sides. And we say that x cannot equal 2. So that's for this first fraction here. For the second one, we have the exact same computation. X minus 2 cannot equal 0, which is what we just solved for. And same thing over here that we had in the previous problem. So 2 automatically does not equal 0, so we don't even have to write that part down. But we do have this, x cannot equal 2. Over here we have x is equal to 4, which doesn't cross any boundaries. It doesn't say that 4 is equal to 2. We have x is equal to 4 as our only solution. And that's it. If you have any questions, pretty please email me, let me know. But if not, bye.